Hey, this is our 102B project video. So I'm going to start first by talking about our motivations behind this. So this is a mock-up of like a solar harvester. So the idea is this entire thing would be floating in space, and it needs to be able to track the sun because the light will reflect off of these panels and will hit this sort of concentrated point here. Of course, in space, the problem is that you can't push off anything, so we have to implement like a reaction wheel design here. So we decided to go with 1 degree of freedom, do a simple like proof of concept sort of situation. So to go over the subsystems of the device, so first we have our sensor, this IR camera here. That's what's going to tell us where our light source is relative to us. That feeds information to our electrical system here that has the ESP32, which is going to have our control systems in it. That's going to determine how fast we need to move this wheel to rotate and correct our errors. Finally, we have the reaction wheel itself right here. So we spin this up in either direction in order to adjust the angular momentum of the system in order to produce rotation. This was particularly hard for us to nail down because the housing itself became quite jittery. It could rotate. There was interference between the wheel and the housing itself. And so we spent a lot of time iterating to make sure the wheel was both of the correct mass so that our motor could drive it properly, and also so that it had good enough interference on this whole device. At the moment, we suspend the entire device using basically fishing wire. And so we also had to nail the center of gravity to be just above the motor here so that we could ignore any sort of issues with weird torques and angles. All right, now let's talk about a particular subsystem we spent a lot of time designing. That's this entire motor housing and reaction wheel system. So the first part is the housing itself has a transition fit with the, let's just say, umbrella. This was actually quite non-trivial to achieve. We had to work with 3D printer issues. We had to get an accurate measurement of the diameter of this and make something that we could both get on and also would have high movement on the rod so as to avoid any kind of torsion or weird extra forces that we'd have to deal with. Moving to the design of the wheel itself, we printed it at a high infill, give it high mass, especially because it's moving quite quickly. We want to make sure it isn't getting torn apart. We also had added places for us to put screws in. This is going to allow us to adjust the weight on the fly. It helped us to tuning our system. So instead of having to iterate on many wheels, we could print the one and iterate by removing and adding the screws in. All right, thank you guys all for listening about our project. Here's a video of it working. Hope you enjoy.